Today we're looking at notes 11-5, add and subtract rationals with uncommon monomial denominators. So what's nice about this lesson is that it's only monomial denominators, and we've dealt with that before when dealing with just regular old fractions. The only difference now is that we will have x's throughout the problem, or y's, or whatever variable. Okay, so when adding two fractions, you already know you have to have common denominators. Okay, so with 4 and 2, the easiest common denominator to get would be 4. Okay, but you could use other things like 8, 16, 20. There's lots of denominators you can get that can be common. It's just that if you use another one other than 4, you'll have to simplify, but you will end up getting the same answer as me in the end once you simplify. So like I said, the easiest denominator to get that would be common would be 4. So I'm going to multiply both top and bottom of the second fraction by 2, because you know that's legal. 2 over 2 is like 1, and you can multiply by 1. So here we would have, I rewrite 3x over 4 plus, this would become 10x over 4. And now that my denominators are common, I can add like the lesson from the day before. So 3x plus 10x is 13x over my denominator of 4. And a couple of things. First of all, I can't simplify. Second of all, there's no restrictions that I need to state because there's no variable in the denominator. So that's nice. All right, moving on to number 2. So my denominators here are 4x and 16x. So the easiest common denominator to use would be 16x. So again, like I've said before, you could use 32x. There's lots of choices, but in my case, I think it would be easiest to use 16x, so that means I need to multiply both top and bottom of this first fraction by 4. Okay, so make sure you distribute when you do that first one, so that would give you 20x minus 4 over 16x. Okay, this one stays the same, plus 2x plus 3 over 16x. Now that my denominators are common, I can go ahead and collect like terms. I'm just adding, not subtracting. So that would give me 22x, and then negative 4 plus 3 would be minus 1 over my common denominator of 16x. And now I know it's very tempting. You want to simplify this, but you can't because that wouldn't be sharing the love to both. So you're just going to have to leave it. The only thing you do need to do is state that restriction that x cannot equal 0. That would create 0 in the denominator, and that is a no-no. Okay, so next example, moving on. So getting a little more complicated here. Okay, I've got 8x for a denominator here, 4x squared for a denominator here. So between 8 and 4, the easiest denominator to get would be 8. So that means I'm going to have to multiply this side by 2. Okay, but I've got x and x squared. That has to match as well. So that means I'm going to have to multiply this guy by x to make that x squared as well. Whatever the biggest exponent is, you've got to get all the other denominators to have that same large exponent. So that means I'm going to have to multiply this side top and bottom by x over x. Okay, and this side top and bottom by 2. Okay, so that would give me on top here 3x over 8x squared minus 22 over 8x squared. Now my denominators are common. I'm subtracting, but I can't combine them, so I get 3x minus 22 over 8x squared. And again, on this problem, and likely on a lot of these problems, you can't simplify, nothing that I can factor out, nothing that I can cancel. So I do need to state my restriction that x cannot equal 0 for the denominator here. And then I am done on that one. Okay, last example. Okay, 3 terms. I'm trying to add this fraction to this fraction and this fraction. So forget about the variables at first. So 6, 5, and 10. With 6, 5, and 10, the easiest common denominator to get would be 30. Now you could use 60 because all of these can easily multiply to 60. But in my opinion, the smaller the number, the better in my case. So I'm going to use the common denominator of 30. And then remember, you have to look at your highest exponent. So that's going to be x cubed. So they all need to be 30x cubed. So if this needs to be 30x cubed, that means I need to multiply by 5x. So 5x on top and on bottom. If this needs to be 30x cubed, then I need to multiply by 6x squared on top and on bottom. And if this needs to be 30x cubed, then I just need to multiply by 3 on top and on bottom. Now here you've got a lot of binomials, so you definitely want to make sure you don't forget to distribute. So I'm just going to come below. That seems easier. So 5x times 2x is 10x squared. Okay, so 10x squared. 5x times 5x, or 5x times 5 is 25x. Okay, over on bottom I have 30x cubed, which is good, plus here I've got 6x squared over, that's going to be 30x cubed, okay, plus 9 minus 24x over 30x cubed. Now that all three of my denominators match, I'm just adding. There's no subtraction in between, so I can combine like terms. So this 10x squared goes with this 6x squared to produce 16x squared. Okay, and then, I wish I had a different color here. I've got this 25x minus this 24x, so that'd be plus x, and then this 9 plus 9 over 30x cubed. Okay, so let's talk. You've got a trinomial on top. If you've ever got a trinomial or even a binomial, the binomials are easier to see, on top or on bottom, you always want to try to factor to see if anything will cancel. So this one's kind of a massive one. With 16x squared out in front, I wouldn't want to play the guess and check game because that's a lot of numbers you're going to have to guess and check. So just so you know, I taught it to you earlier in the year, but you've probably maybe forgotten by now. The way to see if a trinomial will factor is by taking these two numbers and multiplying them. So 16 times 9 is 144. You would be looking for numbers that multiply to 144 and add to 1. So are there two such numbers? And here's the kicker. This is positive, so that would be positive, and that's positive. So are there two such numbers that are going to multiply to 144 but add up to 1? Well, without there being a negative involved here, that is in no way, shape, or form possible. So that means this guy can't factor anymore, which means we're done. We can't do anything else except state our restriction that x cannot equal 0. So I'm going to go ahead and box this up. So just remember, if you're looking to see if you want to even try to factor, use that little trick. If you can't find numbers that multiply to whatever this multiplies to, but adds to this, it won't work.